Gee, you guys sure like to learn, so welcome back. Okay, so you know how many different uses there are for alcohols. You can drink them, use them to disinfect things, or use them as solvents in a chemistry lab. But they're also super useful for producing other substances. And that is exactly what we're going to be showing you today. Okay, so today we're going to be dealing with the substitution of the hydroxyl group in alcohols. And what we're covering today can be used as the first step in synthesizing all kinds of substances. Most of all, it's really going to help us get a general understanding of how esterification reactions work. So make sure you're paying attention. But before we begin, you might find it really helpful to watch our videos on nucleophilic substitutions and leaving groups first. You can find them here. Let's start by looking at the structure of an alcohol. As you know, the thing that makes an alcohol is its OH group. And that's exactly what we're trying to remove when we perform nucleophilic substitution. The only problem is, it's no easy task. Why, you ask? It's simple really. The hydroxyl group OH- is a very reactive entity and a strong nucleophile due to the fact it has 3 free electron pairs and a formal charge on its O atom. So if we want to remove the OH, we're gonna need substances that somehow manage to be even more reactive and which are gonna go after the OH specifically. Yeah, good luck with that. So what do we have now? We protonate the OH group, which means turning that OH into H2O. And since the second H is now bonded with a previously neutral O, the O gets a positive charge. So how did we do that? Well, that's what acids are for. So remember, if you're gonna have OH as your leaving group in nucleophilic substitution, it needs to be protonated to H2O. Alright, now we can get started with the reaction. First up is the SN2 reaction, which occurs when we're dealing with primary alcohols. We'll show you why later. For our example, we're going to use our old friend ethanol again. And we're going to be reacting it with a hydrogen halide. Hydrogen halides are pretty great. They're fantastic acids on the one hand, while on the other hand, they house halogen atoms, which are awesome nucleophiles. The example we're going to be using here is hydrogen bromine, HBr. Because of the electronegatives involved, HBr splits apart in an aqueous solution into an H+ ion and a bromide ion. The H+ will now protonate the alcohol, creating an alkyloxonium ion. In the next step, the bromide ion uses its free electron pair to latch on to the carbon atom attached to the water. At the same time, the bond between O and C sticks to the oxygen. And now we find ourselves in a transition state. The neutral water dissociates and the bromide bonds with the carbon. Our products are water and a haloalkane. So remember, a primary alcohol reacts with a hydrogen halide to produce water and a haloalkane. And the whole process goes through a transition state. Now let's look at the SN1 reaction. This is what goes down when we've got secondary and tertiary alcohols. For our example here, we're going to use tert butanol. And once again, it's going to be reacting with hydrogen bromide. Like before, this process causes HBr to dissociate and OH to get protonated to H2O. The difference between this and the SN2 reaction is that here, the water dissociates just so easily on its own, without much outside influence. The dude just ups and off he goes. Ha! What's left behind is something you're already familiar with, and that's a carbenium ion, an organic molecule with a positive charge on 1C. The last step is where the bromide attaches itself to it, giving us a haloalkane as a product here as well. So what to remember? Secondary or tertiary alcohols undergo the SN1 reaction to produce a haloalkane and water. Why each kind of reaction happens and via what mechanism is something you should already know. But just because we like you, we're gonna go ahead and quickly spell it out one more time. In the SN2 reaction, both molecules play a direct role. The bromide attacks the C atom directly. This doesn't happen in the SN1 reaction, since the carbon here is claimed by 2 or 3 large organic residues that take up their place next to the carbon. On the other hand, the carbenium ion is easily stabilized and the mechanism continues via this intermediate. To sum all this up, a primary alcohol reacts with a hydrogen halide in the SN2 reaction to produce water and a haloalkane. For the secondary and tertiary alcohols, the process follows the SN1 mechanism. If you still feel like learning more about organic chemistry and you want to find out what else you can do with alcohols, just check out the rest of the playlist. Have fun!